Okay, so we're talking inequalities, and we're going to focus, just to start with, on how we interpret graphs, how we use graphs to solve an inequality. Okay, now this would be a common exam question towards the end of a paper, so it's maybe considered one of the more challenging aspects. All right. So, as I say, we're looking at page 640. We're going to go through the two examples. All right. Make sure you can use your calculator to do it. So, first of all, just writing down the inequality that we're given. So we're asked to solve 5 minus 2x minus x squared is less than 0. Right. Now, there is a chance, for instance, we could be asked to do this purely algebraically, just doing numbers right from the start, but there is a chance that we would be given a chart, a graph, to help you. All right? So let's assume to start with that we are given the graph of this function, right? And it looks something like this. Okay. So that is the graph of 5 minus 2x minus x squared. Now, that hopefully is not a surprise to you, because it's a quadratic graph, which you know is a parabolic shape, and it's a negative, so therefore the u is upside down. Okay? Right. Now, what we need to do is look at this graph and say, what does it mean for 5 minus 2x minus x squared to be less than 0? What does it mean on the graph? Any suggestions? Where on the graph would I look at? Because you know the line, we talked about this, the line is where it's, what would I replace this sign with if I was to consider the line? Okay, so it would be equals y, right? So y equals 5 minus 2x minus x squared, that's what the line is. So, right, we've got to consider what the whole less than 0 thing means. So, this value of 0 would be considered the y value. Yeah? Because normally we would be dealing with 5 minus 2x minus x squared equals y. That's the line. So we are actually looking at then where the y value being 0. So where is the function less than 0 for that? Any suggestions? Or have I just confused you? Well, think about when you say that side, you got the right idea, but which axis is the x one and which one's the y one? So y is this one, and this one is the x. So all the values of y are in this direction. So whereabouts is the y being 0 option? Well, equaling 0 is here, isn't it? So that's the 0 on the y-axis. It's also 0 on the x-axis. Okay? But actually, if I move along the x-axis, I've still got y being 0, which is why the x-axis has an equation. What's the equation of the x-axis? Anyone remember? It's a horizontal line going through 0. Therefore, the equation of the x-axis is actually y equals, what if I pick any point on here? Remember we taught this? What will the y coordinate always be?
0.
0. The x-axis is y equals 0. Okay? The y-axis has equation x equals 0. So, therefore, what I can look at is, if I want to know where the y value being 0 is, I should know that's my x-axis. So I'm going to put a line along here. I'm going to highlight that line. So that's the equals 0. All right. So where would you suggest now then that the line is less than 0? Below the line. So this part here and this part here will be the solutions to this. Right? But that's, yeah.
So you said that the highlighted part is the solution to that?
Well, that's all the possible values where, because this line is the 5 minus 2x minus x squared. So these points, anything under the x-axis is when the function itself, this function, would be less than 0. Where is it equal to 0? On the line. Okay, so this point here, sorry. So at this point here, okay, and this point here, you've done this when solving quadratics. This is where the function equals 0, both of those. So below it is where it's less than 0, and this point here, anything there is when it's greater than 0. Does that make sense? Equal to is just those points, those 2 points there. Okay? So anything above the line, we would say is greater than 0. Anything below the line, we say is less than 0, both there. And then on the line, equal to 0. Sorry, that red wasn't very good. I should redo that. So, equal to 0 there. Just that point, equal to 0. Make sense? Okay. Still not solved it yet, but at least we kind of know what we're looking for. I'll let you write your notes. So, if we need to find out where the graph is below the x-axis, we've got to find a whole range of points. So, what we need is to know this x value here, isn't it? We need to know 2 x values. We need to know that point and we need to know this point. And then all the x values basically going in that direction will be under the axis. And all the x values going in this direction will also give a y value under the axis. Does that make sense? So just to do a little sketch just for myself. So from this point and this point, that's that point and that point, I need x values that go that way and go that way, because from there my curve goes under the line. So what are the 2 important points that I still need to find? Those values. I need to know this value here and this value here, x1 and x2. All right? And then I can say, well, x has to be less than whatever this is. Make sense? And I have to say x has to be greater than whatever that one is. Yeah? So it's just about finding those 2 points then. So, any ideas? Okay, so there's a couple of options. We are going to go the calculator option, but having talked about this yesterday and you being so insistent, Smith, how could you solve a quadratic equaling 0? What's your first potential option? The quadratic formula. So remember, it's minus x squared. I'm going to rewrite it. Minus 2. We're not going to do this one, by the way. Minus 2x and then plus 5. And we want to know where it equals 0. Yeah? So we could use the quadratic formula. We could draw the graph on the calculator and find those 2 points. we could also use what option? We can't do general form because that was for straight lines. But what option did I talk yesterday? The tools, yeah, the polynomial root finder, wasn't it? So you've got several options, 2 of them on your calculator, so maybe we should write, maybe you can try both and tell me which one you would choose. So we said polynomial root finder was one option. The other option was draw the graph, okay, and then find those points. Now what I would like you to do for me is do both. Now, just for yourself, work together. We did the polynomial root finder yesterday. Do it, and then afterwards I'll put it on the video. We can show you can tell me what to do with my calculator. So try both options. You decide which one you'd prefer to use. Okay. So we could use the quadratic formula, but we're not going to. We're going to use the other 2 options just to make use of our calculator. Okay, so on your calculator then, let's do it which method? Let's do the thing we used last time, the polynomial root finder first. Okay, so we need a new calculate.
And then you go to
menu.
algebra. Polynomial to
find roots of a polynomial.
Yeah. Okay.
All good. So -1.
Yes.
-1. -2. You know, just to point out, you've been absolutely fine. You've done exactly the right things, but just to refer back to here, if it was written in that order, do you know what people do wrong?
They would write the wrong way.
Yeah, they do it in that order. They'd say A was 5, B was -2, which is fine, but C would be -1. Remember, the A, the first one, is always in front of the x squared. So just make sure you don't make that slip up. So we've got this, click OK, got our roots, press enter, and we've got those answers. Alright, so that means that on our graph here, we've got -3.45, so that has to be here. So -3.45, and the other one was 1.45. Okay. Now, just before we do the other method, these signs here, why are they not and equal to?
Because it's just
anything outside of it.
Yeah, so we look at the question, we only want where it's got to be less than 0. We don't allow it to equal 0. So really, we just check the question and go, right, what have they asked for? Don't offer anything more. So we are saying that these 2 points are what we have just found, but we are only allowed anything below those 2 points. We're not allowed anything else. So that's all these x values. Now, just one other thing, writing them separately like this, would you write them together at all with 1x?
No. I would write them.
So for instance, what if I would write x and I do things like that?
And then on both sides. No, that's... Wait. Yes, you could.
Yes.
Yeah, you could. No, but wouldn't that make... That means x is bigger than both of them. You have to switch from the signs around.
Okay, so if I then said x has to be less than,
Yeah, that would work.
so it kind of technically makes sense, but my suggestion is, because there's a gap in the middle, okay, kind of keep them separate, write them two separately like this, just so it's very clear. All right. If there is no gap between, and we're finding, so for instance, if I was to solve the other one, where it's greater than 0, then I can say x is just between those 2 points and have it as 1. So because it's split like that, it's worth keeping your inequality split. All right? But if I were to say, just out of interest where we've got x squared minus 2x plus 5 is therefore greater than or equal to 0. We are now finding everything above the line, including the 2 points. So this time we could say x is greater than or equal to minus 3.45 and less than or equal to 1.45. So that would be this bit here. Make sense? We've got the two options. Right, let's just go through then. How would you do the same thing, just find the same numbers but using graphing instead? So we go back here, we use graph. So minus x squared, subtract 2x, and then plus 5.
No, you can't do it.
Press intersection. Okay.
Can you do the
What do you do at this point? The grid, and just count.
No, like the actual grid, like when you go to like menu, and
Okay.
then it gives you like
Let's go.
squares.
Menu,
View.
grid,
Yeah.
dot grid, line grid. Okay.
Yes, thank you.
Looks nice. We still can't kind of read a decimal like that, can we? We'd be guessing. How do you find the actual values?
And then it shows up.
Say it again.
Can't you like press it and then it shows up?
Press what?
I'm not 100% sure.
The
But, like
line.
sometimes I just press something and it shows up.
So if you were to press the line,
Like if you press. Like,
Which is blue. Press when it crosses.
press when it crosses.
No,
No.
I could be wrong.
If we go to menu and trace,
Maybe. That's how you do it? I tried to trace.
graph trace. So I quite like this calculator because if you do menu and trace, it gives you the 0, 5. If we then press left and right, it actually does take us straight to that point. In the old calculator, it would bypass that and you wouldn't get exact. But
It's
I've got here, look, x is minus 3.45. I've got it. The y value, 1 times 10 to the minus 12, is just 0. But because of the graphics on the calculator, it can't give it. How do you find the other one? I just press right until I've gone round. Okay, and it will go take me straight to 1.45.
Wait, how can you go
It stops by itself. That's the good thing about this new calculator. It does. The old one didn't. You had to do a specific thing. All right. Just to say, if you press up, okay, or down, it's not going to do anything. Left and right, you're moving left and right along the x-axis, and then it tells you what the answer is.
So wait, you keep pressing it until you get.
I'm just pressing left, left, left. Keep going, and it will stop. At the moment, it's just doing random points.
Yeah.
But when it gets to an important one, it stops for you, and it tells you 0. So that's when it equals 0. So it's really nice.
Wait, so how did you do that again?
So I did that with menu, trace. Trace means to trace the line. Okay. And I just go graph trace, and it gives me a point to shift up and down. Okay. All right with that? So we get the same answers. Okay. Right, let's move on. So we've done those things: polynomial root finder, draw the graph, find the points. We've done it, we've considered it. Let's have a look at the next example, which takes a slightly different, where we've not got an equal a certain amount, but we've got two different functions. So we want to find where, so this is example 2, by the way, 3 plus x is greater than 2 to the power of x.
What? Oh, how wonderful.
How wonderful. Okay?
What seems confusing?
Now, this is definitely one where you're going to be expected to use your calculator. Okay? And what we'll do, what we should do, is you've got two functions here. I'm going to use proper function notation. Function of x, the first one is 3 plus x, so the first function, so that's f of x, which is just another way of saying y equals. We'll look more into that later in the course. The other one, we've got y equals, which is why we use function notation. So I'm going to call this one g of x, just because it's the second one. G of x is 2 to the power of x. So we've got two functions. All right. And we're lucky we've got it in the book, but you'll do this on your calculator. So if you were to do this on your calculator, you will see that one of them looks like that. Which one? F of x or g of x? Have I drawn there? F of x, because it's a straight line. 2 plus x. Okay. Where does it cross?
At the end, y intersection.
And what is that?
Intersection.
3. 3 plus x. Yeah. Crosses at 3. So know that. The other one, the other line looks like this. So it goes, it's an exponential function, and it goes like this. Okay. Goes on forever in those two directions. And this one also goes on forever. Okay. Now, we want to know where 3 plus x is greater than 2 to the power of x. So, any ideas?
You could graph
After they call.
After they cross. Which sides though? So we want where the red line is above the green line. Okay? Maybe I should do that. So the red line is this one. The green line is the second one. Okay? Those two. So we want to know where the red line is above, greater than, the green line. So, where is that? Well, that is between here all the way to here. Now we are interested therefore in the x values that are where they cross. So this one here and this one here. Okay? So where they cross. So we want the solution. Solutions are always the x values. So we want x1 there and we want x2 there. So we need to find those 2 points. Yeah.
I have it.
Okay.
X1 is minus 2.86.
Minus 2.86. Okay.
And X2 is 2.44.
2.4. And what I'll do is I'll get the rest of you to confirm those. We'll use our calculator. Alright. And then we can say that because the line is between those 2 points, we are looking for an inequality where x is between those 2 points. So we've got x should be less than, and we've got no equal sign here, so it must be less than x2 and greater than x1. So we're looking at saying, well, it's minus 2.86 and 2.44, and that is your solution. So, very kindly did it for us, and it's in the example. Okay, glad you confirmed with that. Should we just check with the calculator how you go about doing it?
Yes, please.
You just go to graph and then you do intersections.
So I'm just going to close that window. I don't want that one anymore.
So
Do you want me to stop a minute, slow down? Are you still
Yes,
writing notes?
please.
Okay. Okay, so let's have a look now. So we've got our 2 functions. We're going to graph it. Okay, I want a new one. New graph. How do you do a new document? Doc. New one? Or
I always just click home.
just click home?
Yeah.
Just that and then
Go to
Just
graph.
put new document and click that.
new doc.
Oh, or you could just click
Or I just
graph.
click
Okay. That doesn't look right.
You could just click graph.
Just click graph.
Yeah.
Okay, so we have to put in the first one. So 3 plus x press enter.
That goes all weird.
How do you do a second one? Tab to enter the second one. So we've got 2 to the power of x. How do you put it in?
I did 10. I did the 10 to the power of x one, and then just change the 10.
Okay.
You could do that with the x squared one.
But you could just click the little arrow.
Click the little arrow, yeah. 2 to the power of x.
Oh, I don't know.
There you go. We learn something every day, hopefully. And okay, so we've got it. We've got to find the intersection of the 2 lines then. Any ideas?
Do the intersection.
Menu, graph,
Analyze graph.
analyze graph. Sorry,
No, that's
analyze
not
graph, yeah.
You
Intersection.
can only do one at a time, right?
So we're going to find lower bound. Up about. What if we went double? It finds it there, look. We don't even have to press, look. So we've got 2.44. Can you see it on my screen?
Yeah, I'm fine.
And if I go there, I've got minus 2.86. That's nice. It's a nice thing. It's giving me both separately. But yeah, if I pressed enter, it would give me that specific one. What about the other option we did before? So menu and just trace, graph trace. How about that? So I press left, would that allow me to do it? Well, no, it's just giving me a 0 for that particular graph. It hasn't done the intersection of the 2. It just ignores it. So it's just for that particular graph. Okay. So in this case, because we've got 2 functions, okay, yeah, have to use our intersection. Right. Make sense to everyone?
Yeah.
Definitely in an exam, a calculator style question. Right. So I'll tell you what, let's have a bit of practice then. Exercise 32A. Alright. So exercise 32A. Have a look. Now, obviously, we've got 25 minutes. Don't just start with question 1A and do 1B. Remember what I did before about have a look through first and find where they change something and decide, well, I'm going to do one of each. If you find one hard, do the next of the same thing. If you found that easy, move on to where you've identified the change happens. Does that make sense? Okay. Especially question 5. I'd be interested if anyone did question 5.
What are the bars we need?